So a bit flip of a number x is choosing a bit in the binary representation of x and flipping it from either 0 to 1 or 1 to 0. For example, if x is equal to 7, the binary representation is 1, 1, 1, and we may choose any bit, including any leading zeros not shown, and flip it. We can flip the first bit from the right to get 1, 1, 0, to the second bit from the right to get 1, 0, 1, flip the fifth bit from the right, a leading zero, to get 1, 0, 1, 1, 1. Given two integers, start and goal. Return the minimum number of bits flips to convert start to goal. So if we have an input start is equal to 10 and goal is equal to 7, output is 3 because we have to flip this bit, we have to flip this bit, we have to flip this bit to match this. So at first when I was approaching this problem, I thought the easiest thing to do is to check to see if the index of start, of I and start, or num and start, whatever, is equal to the index of goal. And if it's not, then you add 1 to the output. So it works in theory. If you were to check this to see if it matched up with this one, if it doesn't, then that means that we'd have to flip it to equal each other. So this is not equal to 1 is not equal to 0, 0 is not equal to 1, 1 is equal to 1, and 0 is not equal to 1. So the output would be 3. But the best way to do this is to use the exclusive OR operator. So we can define exclusive OR as start using the caret top thingy-majig, and it's start to the power of goal, but not really to the power. It calculates the difference between each binary representation. So it would go through this, and if the numbers are not equal, then it returns a 1, and if they are equal, then it returns a 0. I think I might have that inverse though. But essentially, we get the difference for start and goal. So now we can initiate. Now we want to convert that difference because it's gonna give us an integer for the difference. So now we want to convert that to binary. So binary is equal to 4. We can use a format, and then we want to convert it to binary. So now that we have that set up, now we can iterate through the list. So now we can iterate through, or we can initiate output is equal to 0. And we can do for item in binary if item is equal to 1, meaning there was a bit flip, then output plus equals 1. And then we can just return output. See if this works. If item, oh, I missed it. Yes, sir, it worked.